A very good morning to all the distinguished dignitaries, the luminaries in the field of chemistry and other allied branches. I think this is the second time during my tenure as the Vice Chancellor of this university. I am privileged to inaugurate the second international conference by this department with the last 3 years. By this time, I'm sure the distinguished guests are comfortably settled and getting accustomed to the weather. In fact, Dibrugarh is a very rare location in this planet in that you may experience all the 6 seasons within the span of 24 hours. So it rains, it gets hot, it gets all kinds of things you get. This university is the easternmost university of the country. There is no state university beyond us. We are very close to the international border. That is the Southeast Asian border. Beyond us, we have cities like Singapore, Bangkok, Kuala Lumpur, and these are the places where you get some of the finest universities of the world. This university has completed 50 years in 2014, and this department is completing its 50 years this year. At the very outset, I take this opportunity and privilege to congratulate those and pay my very rich tribute to those who have really worked hard to bring this department as founders to the level where it is today. I think this is a time where we should really thank them from the core of our heart. This university now has about 36 academic departments and Center for Studies, which offer more than 60 academic programs, right from undergraduate to the postgraduate PhD programs, through 5 schools of studies. We have on campus about 2,000 students, but we have 179 affiliated colleges with a total student strength of about 200,000. So that is a big number. We also have, over the last few years, this university have been able to attract a few international students as well, including the Department of Chemistry, where we have a student from Egypt, yes. And also quite a few, but then it's coming up. Now, when I come to this department and the occasion celebrating 50 years of the chemistry department, I think this is a time when we should really look back and take a few leaves from our experience so that we can take it forward, even to more distant, greater height, and so on. A few reflections on this occasion, therefore, from my side as the Vice Chancellor. The first of all, at this point in time, as you would agree with me, we are passing through different kinds of challenges, not only in the science, but also science actually people are looking forward to address these challenges. And being in the domain of chemistry, what could be our roles in this scenario? This is one. For example, climate change. We need people from chemistry to come forward to address the issues of carbon sequestration, even photovoltaic cells. Things are happening very fast in the field of genomics, molecular biology. And if you go through, I'm addressing the younger students, You'll be astonished to find how many startups, how many enterprises have come up in the United States and Europe by people from chemistry on deep sequencing to cater to the demands of the healthcare sector of the world. Genomics and proteomics are really emerging scenarios in science and technology, catering to the demands of the world population as far as the health issues are concerned. So in these contexts, I go back to history briefly with you. 1897, we have seen J.J. Thomson, the director of the Cavendish Lab in Cambridge, invented the electron. Soon after, we found how Rutherford had come up with the architecture of the atom. And soon after, Niels Bohr came up with the fantastic realization that it is the configuration of the electrons that decide the characteristics of the elements. And this is how we have seen what a historic, what an epoch-making development that took place, the entire realm of science, when we see physics converging with chemistry. Thereafter, many things have happened. 1950s, James Watson, Frederick Crick, when the biologists of the world were getting lost in the details of biology, these two scientists came with a single molecule called DNA and said that God, if not nature, had scripted the language of life, life science, and that is called chemistry because it is a DNA molecule. So what I mean to say is this, that we cannot confine ourselves to the teaching, learning, and research only within the framework of what we call and define as chemistry. We have to go beyond, we have to be more inclusive. Physics, biology, pharmaceutical science, engineering, photovoltaic cell I just mentioned, many things, mathematics. We are operating in the realm of big data. Enormous, massive data sets are awaiting us for exploration, for breaking new grounds in knowledge in science. My only humble suggestion to the young faculties and the young students, scholars of this department and the university is that please break these barriers, these artificial constructs that we have separating physics from chemistry, chemistry from biology, biology from pharmaceutical science, and the rest of it. We cannot have free thinking, creative exploration, and therefore innovation if we confine ourselves within these watertight compartments of physics, chemistry, and so on. This is one humble suggestion. I hope the distinguished, very experienced and decorated scientists that we have amongst us today will agree with me. So this is what we are called increasingly talking about multidisciplinary, cross-disciplinary research. This has been happening, in fact, right from day one, from those days of Thomson and Rutherford and Niels Bohr, James Watson. And today we need those role models. Coming to the other reflection. Only last year, the Royal Society of Chemistry was celebrating 150 years. And I was briefly going through the lectures. These are all available. Two things struck me. Last year, the Royal Society of Chemistry in England was presided over, but not by a distinguished chemist, but by a school head teacher. So what I mean to say is this is the point in time after 50 years, how inclusive are as chemists. The same thing as I have mentioned, physics, chemistry, biology, these inclusivity have to be brought in. we have to look back and find out last 50 years, how many people from this department have really embarked upon a research path in biology, in physics, structural biology, and so on, and even engineering. And therefore to find out a way forward, if not. How many of the students got admitted 50 years back who were females? And how many are there now? How many faculties are female right now? I'm very happy to state that I think this is one of the few universities, state universities of the country, which has a policy on inclusivity, especially targeting the women scientists. We have created small funds for facilitating their research, augmenting their research, facilitating participation of the female faculties and students in international and national conferences, etc., etc. I think this is very, very essential because chemistry, for that matter, physics, and any other branch of science cannot operate detached from the society in order to address the issues of society. So climate change, disaster management, healthcare issues, agriculture, these all can be solved if we have a thorough understanding in a very holistic manner, combining, converging all these domains together. So at this point in time, I think when we reflect on the 50 years and to find out in the light of those reflections the way forward for next 50 years, these are some of the issues. So I call upon the young faculties and the students to really invite, motivate students from other departments, young faculties from other departments, to engage themselves in the deliberations that will be following in the next 3 days. The final reflection is, I do not know how many people are here in the audience today representing the industry. Industry can learn a lot from the academia, and academia has a lot of things to learn from the industry. When we are working in an increasingly globalized and industrialized, market-driven world, I think you cannot cocoon ourselves in academia without looking at what are the requirements of the industry, what are the requirements of the market. So therefore, it is very essential that this university has a multiple industry academia, very active collaborations, and we are in the middle of 3 very important industries of the country: hydrocarbon, petroleum and coal, and tea. We are forgetting, while looking at petroleum and oil and coal and tea, we are forgetting that another very powerful resources just beside us, few miles away, some of you have visited yesterday probably, the river Brahmaputra. This is one of the 27 biodiversity hotspots identified worldwide by IUCN, International Union for Conservation of Nature, way back in 1972. A lot of possibilities for drug discovery, intervention, and all that. And I'm sure without chemistry and engineering and management science, this is simply not possible. While young students, young researchers should aim at conceptualizing, framing your research towards publication in the fundamental areas of the science, there is also a necessity of targeting development products through the research and innovation, which will hit the market as patented, intellectually property right covered academic things. And the third most important, I will conclude with this very few reflections. I think we have to come out in a radical way in our pedagogy of not only just chemistry, of all sciences. We have been teaching our students chemistry, biology, physics, the same way that we have been taught 30 years, 40 years back. I think pedagogy has changed as much as the knowledge has explore that. We require different dimensions, different ways of pedagogy. Chemistry education also requires a special kind of research motivation. And I think this is the platform on which we can deliberate upon all these issues. Right from hardcore chemistry to the market, industry, to the classroom back again, how to teach chemistry and how to make it more inclusive so that everybody can relate to what is happening in chemistry, because it is with taxpayers' money we do our research. Again, in this context, it reminds me of one of the lectures that have been organized during the 150 years of our Royal Society of Chemistry. This was on not chemistry. This was on gerontology. This was on population genetics. So I hope that my colleagues would definitely come forward with more imaginative, thoughtful ideas for this course during this period, the celebration of 50 years. This is the beginning. I think many more different subjects which are really close to every one of us can be accommodated. So with these few words, let me formally declare this 3-day international seminar on the emerging trends in chemical science open. Thank you very much and wish you a very happy stay.